Okay, so all you want to do is be able to graph some functions that are factored. So we don't have to worry about factoring yet. We're going to learn how to factor harder polynomials, but right now they're already factored. So all they're going to ask you is to sketch the graph. So how can we sketch the graph accurately? Well, we know that even degrees are going to have ends in the same direction. Odd degrees are going to have ends in opposite direction. We know positive leading coefficients are going to make the graph go up. Negative leading coefficients are going to make the graph go down. Okay, so let's just go back to this one because we did this one the other day, but I don't know if we recorded it. So from here, we could tell the degree just by adding up how many x's we have. So we have 1, 2, 3 x's, it's degree 3. It's already factored, so we can determine the x-intercepts. Right, so I just take x minus 2, solve for x, x plus 1, solve for x, and x plus 3, solve for x. So we have x-intercepts at -3, -1, and 2. The y-intercept we just put in 0. So it would be 0 minus 2, 0 plus 1, and 0 plus 3, which gives me positive 6. So I could start my sketch by putting these points on the graph. So -3, -1, 2, and the y-intercepts at 1, 2, 3, 4, 5, 6, so up here. Okay, the other thing I know is that it's an odd degree and a negative leading coefficient. So it's odd degree and a negative leading coefficient, right? Because it's got that -1 here at the front. So I know it's going to have ends in the opposite direction and go downhill. So I know it's going to look something like that. Okay? So I know it's going to start here. It's going to go through this x-intercept, through this one, through the y-intercept, come back through this y-intercept, and go downhill. Okay? So I know that based on the degree and the leading coefficient. The end behavior, now I can see the sketch. I can see that it starts in quadrant 2 and ends in quadrant 4. Okay, and then I have my sketch. This one has a square. Okay, and anytime a factor is squared, it's called a double root. So I can determine the degree. I have 3 x's, right? 1 by itself and then 2 in the bracket. The x-intercepts, well, I have 1 here at 0. And then I have x plus 1 twice. So 1 here and 1 here. Somebody has their mic on. My y-intercept I'm going to put in 0. So x is 0, and then 0 plus 1 squared is 0 times 1, which is 0. So the y-intercept is 0, 0. And then what does that look like? Well, it is an odd degree with a positive leading coefficient. So I know it's going to look something like this. Okay, so it's going to start from the bottom. The thing with the double root is a double root makes the graph turn but not pass through. So it's going to turn at -1 at the double root. It's going to turn again, and then it's going to come back up. So a double root turns but does not pass through. Okay, so that's an x-intercept that sits on the line, but when it hits that point, it's going to immediately turn, not go through it, and then come back up. So if you were typing it on Desmos, you'd see it like this. All right, so it comes up at -1, it turns at -1, comes back down, and then goes back up. So that is happening when there is a double root, right? It's power 2. This one, we have 4 x's, right? We have 1, 2, 3, 4. And it's a positive leading coefficient. So if it's an even degree and a positive leading coefficient, I know both ends are going to go in the same direction and they will both go up because it's positive. How many x-intercepts do I have? I have 1 there at 0. I have 1 there at 2. I have 1 there at -1. And I have 1 there at -3. So I'll put those on my x-axis. The y-intercept, I'm just going to put in 0. So 0 times -2 times 1 times 3 is 0, right? Anything times 0 is 0. So 0, 0 is the y-intercept. And then I know the ends are going to go up, right? So I know the ends are going to go up. So it's going to come through this one, through this one, through that, back up, and it'll look like that. Okay, so I have a good idea of the sketch. I'm not too concerned about where it turns right now, just where the x-intercepts are, the y-intercept, and what the ends are doing. And if I look on Desmos, if I typed it in, that's what it looks like. All right, so both ends are going up, passes through my x-intercepts. Okay, I'm just going to do one more. Okay, this one has power 3. So we want to see what power 3 does. So this is still a degree of 4, right? I have 3 x's plus another one at the front. My x-intercepts, well, I have an x by itself, so 0, 0. And then I have x minus 3. So x is positive 3. And so I have 1 at 0, 0, and I have an x-intercept at 3. But that power 3 does something kind of different with the graph. This is a triple root. So what does a triple root do? Well, the other thing I know is the y-intercept is 0, 0. So it is an even degree, and it is a positive leading coefficient. So I know both the ends have to go in the same direction, and they both have to go up. So this end has to go up, and this end has to go up. What it does in between is it comes down at a triple root. It does like a turn, like a wiggle. So this here is the triple root. So it doesn't go straight through like a straight line. It sort of goes like an S, okay? Sort of has that curve. It's called an inflection point. And an inflection point turns and changes. It changes what it's called its concavity. So it goes from concave down to concave up. So it makes sort of like an S. And that's what a triple root does. Okay, so if you see a triple root, you can tell just by the shape. It doesn't go straight through. And the end behavior, it starts in quadrant 2, ends in quadrant 1. Okay, I don't think we did that in the last one. So this one also starts in 2 and ends in 1. And there's the graph. If you typed it on Desmos, then you would see, right, you'd see that S shape goes through, turns, and then curves up. That's the triple root. Okay. See which ones we got left here. Okay, we'll just do one more. So this one is a degree of 4. So I have 1x here, 1 here, and 2 there. The x-intercepts are at -2, +1, and 3. It has a double root. See that there? It has a y-intercept of, let's see, 0 + 2, 0 - 1, 0 - 3, which is squared. So 9, 18, so -18. So way down here. And it is an even degree with a positive leading coefficient. So I know the ends are going to come up. And it has a double root at 3. So it's going to come down through this, go through this one, turn, then let's draw this better. At 3, it's going to turn but not pass through. So it's going to come around, it's going to turn at this point and not pass through. Okay, so my ends are both going up. It passes through -2 and 1, but turns at 3 because it's a double root. Okay, so by the end of this unit, you should be able to sketch graphs based on their equation in factored form right now. We're going to learn how to factor them. But for now, you should be able to sketch based on the degree, meaning whether it's odd or even. And then also the value of the leading coefficient is also going to help you sketch that, along with your x-intercepts and your y-intercept. Okay, are there any questions on sketching graphs that are factored? Next period, or next class we have, we're going to learn how to factor them so that we can sketch them from there. So you will get some questions that are not factored, and you're going to learn how to factor the harder ones, not the ones that we know how to do already, but the ones that are the harder ones, meaning power 3 or power 4. All right, so let me see if there's any questions. What time is it? 2:15. Oh, no, it's 1. Okay, so we got about 10 minutes left in class. I would encourage everybody to catch up on their tasks. The MAP students are actually pretty good. I think most people in the MAP have done their task 1 and 2. If you're ready to write 3 and 4 on the weekend, that's great. We've covered everything. So next week with the MAP, we're going to start Unit 5-6. And then at the end of 5-6 is your first strand test for the MAP. The MCT4C, you've got to complete tasks 1, 2, and 3 and the strand test. So that's where you need to catch up if you're not there yet, which I know there's quite a few of you who are not. So on the weekend, you should be finishing task 1, task 2, task 3, and then the strand test, which is from 1 to 3. Okay, so that when you arrive on Monday, you are all caught up. Okay, are there any questions on tasks or tests?